chemical bonds, compounds, substance in which two or more elements are chemically combined. There are three types of strong chemical bonds: ionic, covalent, and metallic. For ionic bonds, we have particles are oppositely charged, and they occur in compounds formed from metals combined with non-metals. Covalent bonds are when particles are atoms which share pairs of electrons, and they occur in most non-metallic elements and in compounds of non-metals. Metallic is when particles are atoms which share delocalized electrons. They occur in metallic elements and alloys. Ionic bonding. Metal plus non-metal. Electrons in the outer shell of the metal atom are transferred. Metal atoms lose electrons to become positively charged ions. Non-metal atoms gain electrons to form negatively charged ions. An ion is an atom that gains or loses electrons. Ions produced by metals in group 1 and 2 and by non-metals in groups 6 and 7 gains full outer shell of electron, so they have the same electronic structure as noble gas. Electron transfer during the formation of an ionic compound can be represented by dots and cross diagram. Ionic compounds. The giant structure of ions held together by strong electrostatic force of attraction between oppositely charged ions. Since the structure is in 3D, the force acts in every direction. An example is sodium chloride, Na plus and Cl minus ions. Covalent bonding. Share electrons. Small molecules have strong covalent bonds within the molecules. Polymers are large covalently bonded molecules. Giant covalent structures are many atoms covalently bonded in a lattice structure, diamond and silicon dioxide for example. So there could be dot and cross diagram shows that repeat units of polymers using a single line to present a single bond, ball and stick, and 2 and 3 dimensional diagrams. So in the dot and cross diagram, the shared electrons are in the overlap. And then we have metallic bonding. The bonding in a metal consists of positive ions and delocalized electrons arranged in a regular pattern. So metallic bonding, we have positive ions and delocalized electrons. Positive ions and delocalized electrons arranged in a regular pattern. So delocalized electron system consists of the electrons lost from the atom to form positive ions. Delocalized electrons are free to move. And also have they are shared through the structure, so metallic bonds are strong. Yeah. So every ion have the attraction to the delocalized electrons, so they are in fixed positions, so metallic bonds are strong. I think it means this. Okay, this is about the chemical bonds and type of bonding. Covalent bonding is just this simple things, and how bonding structures are related to the properties of substances. So 3 states of matter. So we have solid, liquid and gas. Melting and freezing take place at the melting point. Boiling and condensing take place at the boiling point. So amount of energy need to change state from solid to liquid and from liquid to gas depends on the strength of the force between the particles of the substance. The nature of the particles involved depends on the type of bonding and structure of the substance. The stronger the force between particles, the higher the melting point and the boiling point of a substance. Limitation of the simple model above include that in the model there are no forces, that all particles are represented as spheres and the spheres are solid. State symbols, so solid for S, liquid for L, gas for G, and AQ for aqueous. So properties of ionic compound. Let's just take some notes. So we have regular structures. Regular structures, this is what we have, and also high melting and boiling point. So the regular structure is due to the strong electrostatic force of attraction in all the direction between oppositely charged ions. I think they are because of the structure of the bonding, the direction of the bonding, causing them to have a specific regular structure. Oh yeah, those are called giant ionic lattice. We also have high melting and boiling point, lots of energy required to break the strong ionic bond.下课的话，到时候就6:20下一节课。So the high melting and boiling points are because of the lots of energy required to break the bonds. Yep, and we also have they conduct electricity when dissolved in water or melted, because now they have free ions which can carry charges. The charged particles can carry charges and current. So you can say they conduct electricity when melted or dissolved in solutions. So this is because free ions, the ions are free to move and carry current. The free ions can carry current. So then small molecules, substance that consists of LED gas. I think they're saying about covalent bonds, but we say molecule, we're thinking they are made of covalent bonds. Nah, no one's watching. Small molecules. So they're usually gas or liquid. You can say this. They have a low boiling and melting point. This is all because of its weak intermolecular force. Which is easy to overcome. conduct electricity, they do not have an overall electric charge, or they have an overall electric charge of 0. Don't conduct electricity as they do not have an overall electric charge, or have an electric charge of 0. Don't have an overall electric charge. Okay, then we have polymers, which are large molecule structure, each atom connected or bonded in covalent bonds. Polymers, we can also say large covalent molecules, or you can say just large molecules. Okay, so we would say intermolecular force relatively strong, so they are in solid in room temperature, or we say they have a higher melting and boiling point compared with the small molecules. We say relatively high intermolecular force, so they have a higher boiling point and melting point compared to small covalent structures, or we say small molecules. Relatively stronger. Compared to small structures, small molecules. Yeah. So then we have giant covalent structures.